Now let's try this example. 3.2 grams of cast iron. Now the first thing you need to realise is cast iron is not pure. It is dissolved in dilute sulfuric acid and the resulting solution was made up to 100 ml with distilled water. So we've got our 3.2 grams of cast iron and it's dissolved in the sulfuric. So your iron plus 2 hydrogen ions will give you iron 2 ions plus hydrogen gas. And it's made up to 100 ml. You take a 25 ml portion. Now that's an exact volume, so that goes into the conical flask. And this is iron 2. And we're titrated against acidified potassium permanganate, which is 0.101 molar, and we need 26.45 ml. It tells us to determine the percentage by mass of iron in the cast iron. Now the first thing we're going to have to do is have an equation. So go to your data sheet and pick out the permanganate equation. So permanganate plus 8 hydrogen ions plus 5 electrons will give us manganese 2 ions plus 4 water. And the iron 2 is obviously undergoing oxidation, so the iron 2 ions go to iron 3 ions plus an electron. Now we've got 5 electrons here and we've got 2 here, so we're going to need to multiply this whole thing by 5. So it becomes 5, 5 and 5. Now we can add it together. We've got permanganate plus 8 hydrogen ions plus 5 electrons plus 5 iron 2 ions goes to manganese 2 ions plus 4 water plus 5 iron 3 ions plus 5 electrons. Cross, cross. And now it can be rewritten, putting in your state symbols. Okay, so now we look and see where we can find the mole. And you can see that we've got a concentration and a volume here. So we can find the number of moles of potassium permanganate, which is going to equal the number of moles of permanganate, which is equal to CV. So 0.101 times 0.02645, because it must be in litres, and that comes out to 2.67145 by 10 to the negative 3 moles. Now that we know the number of moles of permanganate, we can find the number of moles of iron 2. So the number of moles of iron 2 is equal to unknown over known times the number of moles of permanganate. So the unknown is 5, the known is 1, so 5 over 1 times 2.67145 by 10 to the negative 3, and this comes out to 0.013335725 moles. Now that's in 25 ml, and we obviously need to know it in 100 ml. So the number of moles of iron 2, we're going to ratio up, will equal 0.013335725 times 100 over 25. And this comes out to be 0.053429 moles. Okay, now if that's the number of moles of iron 2, the number of moles of iron will be, from this equation, you can see exactly the same. So the number of moles of iron will be 0.053429 moles. Now you must make the statement. Okay? Make the statement. Otherwise you'll miss out on potential marks. The mass of the iron will equal number of moles times formula mass, which is 0.053429 times 55.85, and this comes out to be 2.984 grams. So now we're up to finding percentage purity. So the percentage of iron will equal the mass of the pure over the mass of the impure times 100, which is 2.984 over, how much did we start with? 3.2 grams times 100. Let's check out how many significant figures we've got. We've got 1, 2, 3, 4 there, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So our answer should be in 3 significant figures, and that comes out to 93.3%.